And welcome back, students, to another lesson in binary and hexadecimal. We are actually today going to finally talk about what hexadecimal is. So let's just start with a little recall here. We have discussed before that 8 bits can make 1 byte. Well, if you have 2 bytes, how many bits would that be? Well, it's 2 8-bit sequences. And we can actually rewrite a single 8-bit sequence using something called hexadecimal to help compress the digits. Right. Now, I've mentioned this term hexadecimal, but let's actually define it. Hexadecimal, or hex as it's often sometimes called, is a number system of base 16. We already dealt with base 2, which is binary. There's technically a base 8, which is known as octal, but we're not going to worry about that right now. And then there's decimal, which is base 10, what we're very familiar with. And now you have hexadecimal, which is base 16. So you can see most of our systems like to follow the powers of 2. Now, unlike binary, which is simply restricted to 0 and 1, or decimal, which is 0 through 9, hex is 0 through F. You're like, wait, what do you mean F? Well, if you look below, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And I'll talk about it in a minute. And it's really kind of relevant if you use upper or lowercase, though I will note, traditionally a lot of people will use uppercase when you're writing out a hexadecimal code. So it doesn't really matter for our purpose of our exercises, but you should get used to writing in uppercase for what we're going to be working on. Now, why use letters? Because you're probably like, well, what does A mean? What does B? I don't understand. Why can't we just have it like another number? Well, let's just think about, for example, if we want to represent 11. It takes 2 characters in decimal to represent it. Therefore, if we want to keep 1 character per slot, a different symbol is needed. And rather than invent a whole new character that we're going to have to give a name to, and most people will not understand, we simply just decide, hey, let's just go into the alphabet. And so we did. Now, why use hexadecimal? You probably think, okay, this is nice and cool and all, but why? Well, without doing math, can you immediately figure out what 01001110 is? And now you notice it's only 8 bits, so it's not that hard. You probably could figure it out. But what's if you had a string of bits more like following: 1100 001 1100, and so on and so on and so on. There's a lot of bits there. All right, that's a lot of information to process and try and figure out, okay, what do all those numbers mean? All right, you could just try to go through and break it into 8-bit chunks and try to figure it out, but that's a lot of information to try and process. Now, what hex does is it compresses binary down into groups of 4, anywhere from 000 to 111, or 0 to 15 in decimal. So let's look at a quick hex representation of binary numbers. So here we have our binary values, and this is a kind of like handy cheat chart for you if you want to know what are they all going to mean. So when you might see this game when we talk about converting from binary to hex, but here is the values. So for example, I'm just going to go over a couple of these. A binary value of 000 is obviously 0, and a binary value of 001 is obviously 1. You can kind of see those are pretty straightforward all the way up into 9. All right, you just have to think, okay, what's the decimal equivalent? All right. At 1001, still 9. But at 1010, which would normally be 10 in decimal, that's when we start switching over to the hexadecimal values of A, B, C, D, E, and F. Right. Again, this is going to be a handy chart for you to kind of look at when we start doing some of the decimal to hex conversion. But let's talk about representing a decimal using hex. So if we look back at our earlier example here, right, we have 011, or excuse me, 0100 11110. If we look at table series, our previous page, we can find 2 hex numbers for each binary grouping. The binary number 0100 1100 in hexadecimal is 4E. Okay. And when I'm saying representing a decimal here in the title, I'm not actually referring to a decimal number. I should have said representing a number using hex. All right, additionally, this long string that we saw earlier is now represented with C3, CF, 3A, 32. So that is so much nicer. Look at how much screen space alone is used with this hex number compared to this long binary number. Hex is a lot cleaner to use. Now, let's talk briefly about counting with hex. When counting with hex, you go from 0 to 9, and then A to F. I think we've kind of established that already, that it's going 0 to F. However, I want to warn you about being careful. After your initial F, your next number is going to be 1, 0. This is not 10. It is 1 followed by a 0. So you'll have a 1 in that first place value, 0 in the next one, and the next one would be 1. So the next number would be then 1, 1, then 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 8, 9, 1A, 1B, 1C, 1D, 1E, 1F, and then it would cycle around to 2, 0, and the pattern would start all over again. Now, base 16. I have a little quick table here. Because remember how in binary we represented each place value as power 2? Same thing can occur in hex. If we look at this table, you can see how so few place values can hold a lot of information compared to binary. So with power 16, right, 16 power 0, that should actually say 1 there. That's a small typo, ignore that. That should say 1. 16 to the power of 1 is 16. 16 to the second is 256. 16 to the third, 4096. So with just 3 place values of hex, I'm going up to a place value equivalent in decimal of 4096. That is huge. So you can see base 16 can contain a ton of information compared to decimal, and it just destroys binary and how condensed it is. So this is just yet another reason why hex is very much preferred. And that concludes our notes, ladies and gentlemen. Until next time.